Okay. Welcome everybody to Handle with Care, a guide to stopping the spread of germs. I've got some content planned out for you today, going through some basic biology. We're going to go over different techniques and different skills that you can have to prevent yourself from getting sick in the first place, and also things that you can do that if you do get sick, how to keep other people from getting sick, and how to allow yourself to recover as quickly and as efficiently as possible. So if you have any questions at any time, please feel free to ask. There's no stupid questions at all. I promise I will explain anything from any single term to big concepts. The only hard questions might be if you ask the same question 20 times. I might get a little tired after that, but feel free to ask any questions you'd like. All right. Okay, so like I said, learning points for today, we're going to learn some of the basic biology behind disease transmission. We're going to learn tools to prevent the spread of germs. So, starting off with some basic definitions, what is a disease exactly? So diseases are illnesses that affect plants and animals. There are many different types of diseases. We'll kind of go over some of those types later on. Diseases can be caught, inherited, or can develop over time. So we kind of have those different concepts of things like the flu, that's a disease, but also things like cancer or heart disease, those are diseases also. So we're going to specify a little bit what exactly diseases we're talking about. Okay, so as I mentioned before, there are two different kinds of diseases, two broad categories we can put them into. We have communicable diseases, so diseases that we can share amongst each other, and non-communicable diseases, diseases that we cannot share, non-infectious. All right. So, communicable diseases. Communicable diseases are infectious. They can be transferred from one organism to another. The common cold is an example of a communicable disease. Right here we see kind of an illustration of bacteria. So things like bacterial infections are communicable diseases, whether that's lung infections or skin infections. Typically those are transferable person to person. Now, not all bacterial infections are communicable, but most tend to be. Now we have non-communicable diseases. And I know I'm moving quickly. Any questions so far, communicable versus non-communicable? All right. So non-communicable diseases, yeah, Arlene. Yeah, so genetic diseases, for example, like sickle cell anemia, that's this little illustration is showing those sickled cells that you would see in sickle cell anemia. So yeah, sickle cell or Tay-Sachs or all kinds of different things. There are lots of illnesses, typically cancer, is a genetic disease. Oftentimes, it can come about through environmental means, but typically if you're having cancer, you are genetically predisposed to a certain extent. So like we said, they can't be transferred between one organisms and another. You can't give somebody cancer. Things like chronic lung disease, if you have a genetic predisposition to COPD, you can't transfer that COPD to somebody else. Now, if you're in the same environment, say that, you're 5 people working in a coal mine, you may all develop COPD, but that's environmental exposure, not necessarily transference of the disease from person to person. Okay. Any questions, comments? All right. Viruses. So in the year 2020, we got pretty well acquainted with a virus. I don't know if anybody remembers that. So yeah, the COVID-19 pandemic, that was the result of a viral infection that went across the globe. So really impacted almost everybody on Earth. So a virus is an infectious microbe consisting of a segment of a nucleic acid. So that's kind of the base building block of DNA. So either DNA or RNA, surrounded by a protein coat. So proteins, we think about this, if you're talking about nutrition, we think about proteins like steak and meat and sometimes beans and rice. Protein in this sense is talking about the very foundational level of protein. So you have that little DNA molecule at the center, and then you have molecules of protein surrounding that DNA to protect it. A virus cannot replicate alone. So one thing about viruses is they are not living organisms. So they require other living organisms in which to replicate, which is why we get viral infections, is they're floating around through the air, and then we inhale them, and they kind of hijack our own cells to replicate that virus. So, like I said, it must infect cells and use components of the host cell to make copies of itself. Oftentimes, a virus ends up killing the host cell in the process, causing damage to the host organism. Well-known examples of viruses causing human disease include AIDS, COVID-19, measles, and smallpox. So, as you can see in this sentence, causing damage to the host organism, oftentimes viruses want to be in this very, very specific point where they want to get their host organism sick, but not too sick where the virus kills the host before the virus can replicate and expand. So you can see this sometimes with other viruses that are even more deadly than COVID-19, that they don't spread very quickly because they're killing their host prior to spreading that virus to more people. So COVID-19 was particularly infectious because it had a relatively low mortality rate and a very, very high R value, which is basically how quickly that virus can replicate and spread. So COVID-19 was very efficient at not killing its host organism, but spreading its viral material quickly and efficiently. And things like measles and smallpox, very, very common, largely eradicated in the 1900s, although now we're seeing some cases, especially of measles in the United States. As people are more and more hesitant to receive vaccinations, we're seeing measles kind of come back. And we'll talk about vaccines as well a little bit later. Any questions about viruses, the way they replicate? All right. Okay, now we're on to bacteria. So these are kind of our two main, when we're talking about communicable diseases, we have viruses and we have bacteria. So bacteria are small, single-celled organisms. Bacteria are found almost everywhere on Earth and are vital to the planet's ecosystems. Some species can live under extreme conditions of temperature and pressure. We see some bacteria species living all the way at the bottom of the ocean next to geothermal vents. So bacteria are truly one of the more foundational species on Earth, and they are incredibly plentiful. The human body is also full of bacteria, and it's estimated, in fact, that bacterial cells are more plentiful in the human body than human cells themselves. So it's kind of funny, you're more bacteria than you are a person. So most bacteria in the body are harmless. Some are even helpful. A relatively small number of bacterial species actually cause disease. So when you hear things about, if you've ever heard the term gut microbiome, you might have heard that on a commercial or on certain things. So your gut microbiome is the specific type of bacteria that live in your gut and help you through processes of digestion, absorption, and things like that. So, lots of companies sell kind of probiotic drinks and foods, and that's intended to feed your microbiome and make sure that the positive bacteria in your gut are flourishing and the negative bacteria in your gut are diminishing. And so sometimes when people have, gastrointestinal issues, sometimes that can be an imbalance in their gut microbiome. Okay. All right. All right. Here we go. All right. Now to talk about a specific kind of bacterial infection, we're going to talk about urinary tract infections. The urinary tract infections happen across all ages, across all genders, but especially in older adults, UTIs get more common and they also get more severe. They show symptoms in different ways. If you're younger, typically a UTI kind of presents as, painful urination. You might even have that feeling that you need to urinate frequently. Sometimes it's more obvious the younger you are that you have a UTI. When we get older, so it says that here UTIs can cause a wide range of obvious physical symptoms. In older adults, a UTI can be much more discreet, but lead to significant physical and mental changes. One of the most common symptoms of a UTI in older adults is sudden onset delirium or confusion. You may also see changes to dizziness, lethargy, behavior, and other physical changes. Due to a weakening immune system, UTIs can even rapidly become kidney infections, which can lead to sepsis. So if you don't know, sepsis is basically when an isolated infection, whether that's a bladder infection, a skin infection, or otherwise, enters your bloodstream and essentially infects your entire body. So at that point, it becomes incredibly dangerous and difficult to treat because that infection is now throughout your whole body. And the antibiotics used to treat that infection also damage your other non-bacterial cells. And so when you get into sepsis, that truly becomes a life-threatening illness. Now it's not common. I wouldn't say you have to be excessively scared of a UTI, but it is possible that if you wait long enough or are even unaware that you have a UTI, it is possible that it can progress into sepsis. Although typically kidney infections have pretty strong symptoms as well. So you'd likely notice once it gets to the stage of a kidney infection, you'd typically notice symptoms that would make you see a healthcare professional. So kind of what we talked about with some of those symptoms, sudden onset delirium or confusion, this is one of those things where, especially in older adults, and we've seen this here in this building, of all of a sudden someone has a significant change in their behavior or their memory, where they go from very high functioning to someone who may seem more apt to be in memory care. And you say, how is that possible that someone goes from a good baseline of cognitive function and all of a sudden within days has extreme levels of delirium or confusion? And that's where that UTI can come in. It's very common that we say, okay, this person has had a significant change in their baseline. Let's get them a test for a UTI. And more often than not, that's typically the case. So we can kind of see this here. This is our bladder right here. So typically a UTI is just in the urethra. So just in that tube in which urine comes out from your bladder. That's the first stage of a UTI. Then a UTI can progress all the way into a bladder infection where the bacteria has made it into your bladder, can even cause things like biofilm where the bacteria itself accumulates on the walls of your bladder. And then the next stage is this kidney infection with the bacteria going up against the flow of your ureter into your kidneys. And then if that bacteria gets out of your kidneys into your renal artery or into your renal vein, that's when you start to talk about things like sepsis. Yeah, Connie.
How do they check if it is a urinary tract infection? Is that a blood test or is it a urine test?
Yep, so it'll be a urine test. So it's typically a pretty simple urine test. You can even do them here. You know, if they have a nurse that could come by, have you just urinate into a cup, and then they take it, test it for that bacteria, and then they can also determine what bacteria exactly is causing that UTI and typically get you on an antibiotic that targets that UTI. And then if you're having symptoms, it typically resolves in probably 1 to 3 weeks. Sometimes sooner, sometimes longer. Just depends. Of course.
Isn't it, some people are how do you say it? Can get that more often than other people?
Absolutely, absolutely. And it's also something we see that if you've had one UTI, you're much more likely to have another. So it's just one of those things where if you're getting UTIs, it's not unexpected that they may recur, but it's also beneficial that if you've had one before, you can know what symptoms to look out for. So you can say, okay, I'm suddenly very confused. I'm having some of these physical symptoms. I'm having some of these other symptoms, sudden lethargy, sudden dizziness. Now, it's not always the case that it's a UTI. You know, there can be lethargy and dizziness or other things for other reasons. But typically, if you're having a very sudden change to physical or cognitive, you know, performance, a UTI is pretty common. Let's see. Okay. So I'll talk a little bit more about how to prevent UTIs. So preventing UTIs, one, hydration is very, very important. The more often you're using the restroom, the less it gives that bacteria a chance to colonize in the different areas. So if you're staying hydrated, urinating frequently, essentially you're washing out that bacteria. So the more you urinate, essentially the better. Now, granted, you don't want to be going to the bathroom every 5 minutes, but staying adequately hydrated, you can always check after you've gone to the bathroom to see what color your urine is. If it's a light yellow, that's right about perfect. If it's all the way clear, that is a sign of overhydration. If it's completely just water clear, that's on the end of overhydration. And then as you get into darker yellows, or even if you start to see light browns, that's a sign that you're dehydrated and that you should hydrate. And one of the things we also say is hydrating sequentially throughout the day. So not, you know, wake up in the morning, have 3 cups of water, and then not drink anything, you know, for the next 4 hours and then drink a bunch of water and then not drink. It's better to, you know, have a glass of water every hour and a half to sequentially put water into your system. And then also hygiene is very important. If you happen to use, you know, adult diapers or anything like that, it's very helpful to keep those clean, replace those often. And then also when you're in the restroom, using good hygiene while you're in the restroom, washing your hands, showering frequently, that can all help prevent that bacteria from colonizing in the first place. All right. So now we're going to talk a little bit about hand washing and why hand washing works and why we should do it. So a soap molecule has a head and a tail. So you essentially have a little round head and then 2 tails that come off. And it allows soap to basically bridge the gap between oil and water. Because oil and water is hydrophilic, meaning it likes water, and oil is hydrophobic, meaning it hates water. So what soap allows is the water from, you know, the faucet or wherever you're washing your hands. It allows that water from where you're washing your hands to connect with all of the oils on your hands themselves and take all of that oil away, which might have trapped bacteria or other things on your hands. All right. So when salt molecules dissolve in water, they arrange themselves into spherical clusters called micelles. So all of those heads kind of form a circle or a sphere. I'll pause.
She's out.
Okay. All right. So yeah, when the soap molecules dissolve in water, they arrange themselves into spheres. And then those hydrophilic heads on the outside and the hydrophilic tails on the inside. So they kind of pick up all those oils off of your hands, and whatever bacteria or viruses or otherwise are clinging to the oils of your hands, the soap helps attract and pull those off. So that's where just water itself doesn't clean your hands nearly as well as soap and water, because it's almost like if you are to pour a glass of water into a glass of oil, they're just going to separate. But if you put soap in with that oil and pour water in, they'll emulsify. So coronavirus, for example, has that core of genetic material like we talked about. And then outside it has what we call a phospholipid bilayer covered in spike proteins. So that fatty layer repels water and protects the virus long enough that it can get into our system and infect our cells, like we talked about, of how viruses replicate. So when we wash our hands with soap, The hydrophobic tail attaches to the virus's fatty outside cover, that phospholipid bilayer. And that's a really fancy term for just two of those heads and tails kind of connected in a layer. So then once that soap molecule attaches to the outside covering of the virus, it pulls the virus apart, basically dismantles that outside of the virus, exposing the DNA on the inside and killing the virus. And then you add water and it washes all of those viral parts and all of the oils off of your hands down the drain, rendering any bacteria or virus on your hands useless. All right. So here we have a really simple, non-complicated image. Just kidding. It's but this is just kind of a basic display of what a phospholipid bilayer looks like. A lot of this stuff we can kind of ignore, but you can see these spheres up here. These are your heads. So you've got your hydrophilic head, and then you can see the little tails branching down here. Those are your hydrophobic tails. And they're kind of right next to each other with the tails touching and the heads all the way apart into this dual-sided layer. Here we can see these proteins. So in our own cells, these integral or intrinsic proteins are what allows us to move things in and out of our cells. So you have these proteins that are activated by different ions that allow things to move in and out of our cells. Otherwise, things would just get trapped on one side or the other of this bilayer. Okay. Yeah.
So I can see where that would be soap, right? And that one. Does it also get rid of bacteria?
Mm-hmm. Yep, absolutely. So this would kind of be the outside of a cell. So this could be the outside of a virus. This could be the outside of a bacterial cell. This could be the outside of, a normal human cell. So when we're washing our hands, the tails will, or I guess, yeah, let's see. Hydrophilic. Yeah, so the water will attach to these spheres on the outside, whether it's a virus or a bacteria, attached to the outside of that cell and kind of dismantle it and wash it away. Okay. So now for a really common question, what about antibiotics? So antibiotics work very specifically for bacterial infections, but they do not work for viral infections. So antibiotics are specialized medications that work to treat bacterial infections, but they do not work against viral infections. And so oftentimes, one of the really common examples is something like a sinus infection or an ear infection, because both of those can have either bacterial or viral origins. So it's very necessary when a doctor is going in to attempt to treat a sinus or ear infection to know what kind of infection it is. So doctors are now doing a much more specific job of prescribing antibiotics only when necessary, because now we're coming up to the issue of antibiotic-resistant infections. So different infections that we've had for years and years are now developing resistance to the antibiotics that we used to treat them. And since doctors would prescribe antibiotics so frequently, those bacteria had a chance to adapt to the antibiotics used to treat them. And so with viral infections, we don't have anything equivalent to an antibiotic. We do have antiviral medications or retroviral medications, but those don't exactly treat viral infections as specifically as antibiotics do. They typically, bless you, they typically allow you to rest and recover more efficiently. They make that recovery process more streamlined when it's something like a viral infection. Okay, Is it too cold in here?
Yes.
Okay. I didn't mess with the thermostat, but okay. Any questions about antibiotics, viruses, viral infections? Okay.
You can talk about sepsis.
Yeah, I can talk a little more about sepsis. Do you have any specific questions about it?
What is
Yeah. So sepsis is basically when an isolated infection becomes system-wide. So it enters your bloodstream and then it goes all throughout your body, infects your liver, your kidneys, all of your other organs. And so sepsis is truly one of those illnesses that doctors are afraid of. If you ever hear a doctor say, hey, so-and-so is going septic, or you are going septic, that is code red. That means that that infection has spread all throughout every system in your body, and they're going to have to use broad spectrum antibiotics to fight it. Life-threatening. And it's life-threatening for anybody of any age. Now, it's typically more difficult for someone young and healthy to have an infection progress to sepsis. So, you know, you're not going to see as many young people being diagnosed with sepsis because their immune system is more active and preventing that wide-scale infection of the body. Now, once that diagnosis of sepsis occurs, anybody of any age is at a life-threatening stage. Because once sepsis occurs, even for a young person, their immune system might be more active in fighting it off. They might have what we call physical reserve. You know, they might have strength, you know, their muscle tone might be more accurate. So a younger person might have better chances of surviving a septic diagnosis, but it is equivalently life-threatening no matter what age you are. And especially for someone older who does not have what we call physical reserve, you know, maybe they're already at a point of, you know, frailty or having low muscle mass or any of those things, sepsis becomes a much more life-threatening diagnosis for someone who's older. Absolutely. Yeah, Diane?
Is it always a bacteria or is it?
Yes.
Can it be a virus?
From what I understand, sepsis is almost always bacterial in nature. Now, you could go into some sort of viral sepsis. Typically, I don't think they typically classify viral infection as sepsis, because what viruses typically do is they damage specific systems. So a virus like COVID-19, for example, COVID, you know, damaged a lot of people's lungs, their heart, their liver. And so viral infections can specifically damage one system of the body where that viral load is concentrated. So you're not going to typically see sepsis of the whole system. You know, you're not going to see it in the blood. You're not going to see it through all organs. Bacterial infections, you may well see through every organ system in the body, depending on the progression of sepsis. So yeah, typically bacterial, not viral.
And can it, you know, like, for example, can you get sepsis from different kinds of bacteria? Like a person could be dying, be septic because they have a uterine infection, another because they have a bacterial infection or something else.
Absolutely. Absolutely. So kind of like we talked about with UTIs, you know, someone could be septic from an infection that began as a UTI. Other people, so strep throat, for example. Strep throat is an illness that we typically don't consider life-threatening. You know, we say, okay, we got to go get antibiotics, we treat it. It's typically a very mild illness, all things considered. But from what I understand, I don't want to misquote myself, but strep throat can then turn into scarlet fever. And scarlet fever is that progression of strep throat into a more widespread infection. And that scarlet fever is life-threatening. And so that would be the septic progression of the strep throat. So yeah, you can really have any kind of infection become septic. And we saw that a lot, you know, in the Civil War, where, you know, people would need surgeries or amputations or would even receive a cut on the battlefield. And in an era where antibiotics did not exist, small wounds in the Civil War could lead to septic infection and cause someone to die. And so we're very lucky to be living in the age of antibiotics. And now we're on the other side of the coin where we used antibiotics so much that now we're creating antibiotic resistant bacteria that are kind of getting us back. Not nearly, not yet, but the concern is that we will be back to that time of the Civil War where we don't have any antibiotics that work against these bacteria. And there are certain infections that do exist right now that are resistant to many antibiotics. So MRSA, for example, or methicillin resistant Staphylococcus aureus is MRSA. Say that 10 times fast. But MRSA is an infection that you see very commonly in hospitals because, you know, you have people who are on antibiotics, around antibiotics, and so MRSA sticks around. And it's one of those where you have to get placed on very heavy, broad spectrum antibiotics to clear a MRSA infection. And it is scary, but it is pretty rare. So don't be too scared. Okay, any other questions? Perfect, we'll move on. All right, vaccines. So vaccines are vaccines are our best equivalent to antibiotics, but in a viral sense. Now, granted, vaccines are prevention, not treatment. So vaccines, like I had just said, vaccines are one of our most effective interventions for viral illnesses. Vaccines essentially tell your immune system what the virus looks like and helps identify the true virus when it shows up. Think of it like posting the mugshot of a troublemaker on the bar of a saloon. And when that troublemaker walks in the front door and you look at the poster and say, that's the same guy, you kick him out. And that's really what vaccines are doing for your immune system. They're saying, here is what this virus looks like. Your immune system attaches to that vaccine version of the virus, an inert or dead version of that virus. And then it says, okay, we know what this virus looks like. And if we are to be attacked by a true viral infection from this virus, we are prepared to fight it. So as you may have heard during COVID, they said vaccines do not prevent infection. And that's true, they don't. Because you can still become infected with COVID-19 even if you've had all of your vaccines. What the vaccine tends to do is it reduces the severity of the infection. So it allows your immune system to respond more quickly and more effectively. So your immune system can say, okay, we've seen this before, we are prepared to fight this. Non-vaccinations, that virus might get up to a certain load before your immune system ever begins to fight it. And so really it helps prevent those most severe cases, but it does not prevent infection. I had all of my COVID vaccines and boosters when they were recommended. I still had COVID. I still had relatively difficult time with COVID, but there is some likelihood that if I were unvaccinated, that I could have had even more severe illness. So it's a difficult give and take, and some people struggle with that concept of vaccines not preventing infection, because you say, well, why am I getting this shot if it's not preventing my infection? And really it's why they recommend vaccines, especially for people over 65, is your immune system has declined, something we call immunosenescence. All of your immune cells are getting older, less effective. And so it's even more important the older you get to get vaccines to say, hey, you know, we've got this 85-year-old barkeep and he needs to have that mugshot behind the bar to know who to not let in. And so, yes, you may still get infected, but hopefully your immune system is more effective in fighting that infection. All right. We feel good? Okay. Yeah, Elizabeth.
So many side effects and dangerous things when people get the COVID vaccine.
Sure.
But then I had all kinds of stuff from the COVID vaccine.
Sure.
So why is it?
Yep. So for most vaccines, now there's different kinds of vaccines. There's mRNA vaccines, but there's also what they call inert vaccines. And what inert vaccines are is they're putting they're putting that virus into the vaccine, but it's the dead version. So they're essentially putting the parts of the virus into a vaccine and sending it to your body. So despite the fact that you're not being infected with the virus, your immune system is still mounting a response. And so you are, to some degree, when you get a vaccine, simulating infection. And so that's where you can have all those side effects. You can have the fever, the body aches, the chills. You can have some of those smaller symptoms of infection because your body is still witnessing that virus, but you're not actually infected. So it's really that your body mounting that immune response that creates many of those side effects. Now, sometimes it could be, most vaccines are, deemed to be safe, by the FDA. They go through tons of clinical research, but there are sometimes ingredients within vaccines, whether it's shelf stabilizers or different things that make the vaccine effective. Sometimes people can also have allergies to certain ingredients in vaccines, and that's where the other side of those side effects can come in.
I had to go to the doctor for
Mhm.
and during that COVID thing where you had to take the booster or you couldn't work.
Right.
So I got to be friends with a lot of the young nurses there that were pregnant.
Sure.
And all of them lost their babies because of the COVID booster. And that's what was stated. So why would that affect a baby that you had? I don't understand that.
And I would be, that's a good question, first and foremost. I would be surprised for the women who lost their children. I would be surprised if all of them lost their child directly due to the COVID booster. I would be surprised if that was the case. Again, things go through clinical trials. All of